Hello everyone, welcome to our channel Code with Sunny, and in this video I will be talking about the very easy problem to sum. Note that its index is 1, okay, and it's an easy problem, okay. So without wasting our time, let's discuss this problem. Given an array of integers nums, we'll be given an array of integers, okay, and an integer target, and we have to return the indices of two numbers such that they add up to the target. So there must exist any two numbers. Note that the two numbers must have the distinct indices, so that if we add up these two numbers we get the target value, and that target value is given to us, and we need to return the indices of such two numbers, and we may assume that each input would have exactly one solution. So there exists a solution, and there exactly exists only one solution, and we may not use the same element twice. As I've already said, the indices must be distinct. We may return the answer in any order. So what could be the best solution and the approach to solve such type of problems? Let's understand this one. Okay, so what I am going to do is okay, so let me first change the background. So suppose that, let's take an example, like if we have an array like this one, 2, 3, 5, 7, 9, 11. Okay, note that I'm taking the array in this sorted form, and if we need to find out a particular element, we need to find out two elements, ai and aj, such that if we sum up ai and aj, it must be exactly equal to the target value. Note that I have assumed that we are going to work upon the sorted array. Okay, so the sequence of steps are very much similar. You are going to use a two pointer technique. So what is this two pointer technique? You are going to place one of the pointer, that is the start pointer, at the beginning, and end pointer as the end of the array. Now you are going to find out the value of a of s and a of e. Okay, and suppose this is exactly matching with the target, then you are done with that, and you're going to say, yeah, we have found out the two indices, and the indices is exactly equal to s and e. Okay, and what about that? This sum as plus ae, let's call it as capital S, is going to be strictly greater than the target. In that case, what you are going to do is you need to decrease this capital S. Capital S is the sum of these two elements at the respective indices. You can see that if we try to increment increment my start pointer, then obviously s will increase because we are moving to the next greater value. Okay, and what about if we try to decrement e? If we try to decrement e, then the s will decrease, and the probability of getting, like, not saying about the probability, we are going to approach the target value fast as possible. Okay, so the optimal case in this case is if the sum as plus ae is going to be strictly greater than target, you are going to decrement your end pointer, and if s is strictly less than the target, you are going to increment your s pointer. And this case that I've already dealt with, that if it is exactly equal, just going to return s and d, where the s and d are the indices. Okay, so you can see that in the initial case we have not been given the sorted array. Okay, so the approach is similar. We are going to sort the array. So the very first step is sort the array, and sorting is on the basis of the first pair would be like nums of I, and the second element of the pair is like I. We are going to sort on the basis of this condition, nums of I, and correspondingly pairs will be sorted. Then we are going to apply the approach concept of two pointer, and whenever we will encounter this condition, return the second element of the pair as your indices. Okay, this will be your answer. So this is one of the step that I am going to talk about. And another thing is, like, you can use a hash based technique, and I'm going to say I'm going to use an unordered map. So what this is going to do is like traverse. Okay, so yeah, we are going to use unordered map. So the first, like, we are going to have two things. This is the first key and correspondingly value. So this, like, key is going to denote the nums of I, and the second element is going to denote the corresponding index where the nums of I is present. Okay, and we are going to traverse in the array starting from the 0. Okay, so traverse in the vector, let's say, starting from the 0, and every time I am going to check if a particular, like if I'm talking about this nums of I, and if we have target, like we want to achieve the target, and if we subtract the current value, if target minus nums of I, so this is my required value. If it is already existing in this map, then we can easily say that yes, we have already found the pair, and the pair is going to be given by MP of, let's call it as this, as MP, and MP of target minus nums of I, which will give us the index of the second element, and the other element is the current element. So this is our answer. So if we have at any time target minus nums of I already in this map, we are going to return this as our answer. Otherwise, we are going to push up the value, and the value is like MP of nums of I is exactly equal to I. So these are the steps that we are going to perform. So let's head over to the code and check it out if we have an efficient solution regarding this one. So you can see that the very first thing that I've done is like sorting on the basis of vector pairs. So what I've done is like maintained a new array, and I iterated over all the elements and push up the nums of I and I into the vector and sort this new array. So and again this L pointer is taken as 0, and int pointer r is going to be taken as nums dot size minus 1, and just do the two pointer approach. If it is exactly equal to the target, return your answer as array of L dot second and array of R dot second. Otherwise, if it is strictly greater than target, decrement your end pointer, else increment your start pointer. And this is for like we need to return something. Okay, so that's why I've written over here. Actually, this condition will never reach. Okay, so let's move on to the unordered map based solution. You can see that I maintain a mapping of nums of I and its index, and just iterate over this array, and anytime you're going to find out the target minus nums of I, which we are searching as another element, and if it exists, return the pair, which is our answer. Otherwise, you need to push up the nums of I and I in your unordered map. Okay, so this is the solution regarding this one. Okay, so talking about the time and space complexity, it would be like sorting takes n log n, and you can see that space in this case is like O of n, and in this case also O of n, and okay, but in this case unordered map is going to take like insertion and deletion O of 1 operation, and also you can see that we have the space complexity of O of n. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and to subscribe to our YouTube channel for latest updates. Thank you for watching this video.